Alright, so this is sort of working in reverse. We're not given any functions. All we're given is some information about our functions. And so what we're going to do here is, well, given information about our functions and its derivatives, what possible function could this be? Now, again, my note here is that your answers might vary because there are multiple functions that have the same characteristics. But the graph should reflect certain shapes, certain characteristics. So the first example is just a simple one. If f is decreasing and concave down from negative infinity to 3, so again, my function should be moving in the downward direction. So again, should be moving down and should have the concave down. And again, usually the concave down in these cases can be like a half concave down, right? But it should have sort of a curved down shape to it, which means the first derivative should be less than 0 and the second derivative should be less than 0. Alright, f of x is decreasing and concave up. So again, still moving down, but then the concavity changes to concave up. So the first derivative is still negative, but now the second derivative is positive. 3 is sort of the magic place. 3 is the point where it switches concavity, right? It's still decreased, so it's not a turning point, it's not a max or a min. Decreased on both sides of 3. But concavity changed in 3, and so that tells me at x equals 3, the graph should reflect that it's an inflection point. Specifically, inflection where it's switching from concave down to concave up. And so what it is the shape that comes out is that sideways S shape. And so where it could vary is where you graph the function, how steep you make it, how curved you make it, where you plot your point. All right, so again, at x equals 3 is sort of you could plot your point anywhere at x equals 3. So I'm just going to pick a random place. So that's the point 3, f of 3. I don't know what f of 3 is. That's why it could be 10, negative 10. This is where answers could vary. But this should reflect that it's an inflection point. So my graph, at the very least, should show that that's an inflection point. Specifically, concave down, switch to concave up, and then it should be decreasing the whole time, except for maybe at that moment. All right, so this should have a concave down from negative infinity to 3, and so again, cup down shape. Curve than what I was starting to draw there. There. Alright, something like that, right? Concave down and decreasing. You'll see there's the concave down shape. It's a half concave down. And my functions was decreasing, right? It's moving slowly down, but it is decreasing, right? My values are getting smaller. Then at this moment, it switches concave. So basically has now a concave up shape on this side. Alright, so again, this is where the graphs vary, but it should have this sort of S shape. Concave down, switched to concave up, decreased the whole time. You'll notice that, so again, concave down, decreased, inflection. So this would probably be a place where my derivative didn't exist. It would be a vertical tangent case. Didn't say that, but more than likely that's what's happening. Decreasing and concave up. So again, your graph could vary depending on how curved you made it, where you placed your point. But at the very least, it should have this basic shape to it in some varying degree, where this moment is at 3 and some function value. All right, usually on the homework you pick one. You pick the shape that represents this the best. So again, there are multiple right answers if you're just drawing it, but you want to make sure it has this shape. All right, second example, there's a little more work to it. All right, example 2, they give you a whole bunch. Actually, sometimes when they give you more information, it's harder. All right, so we've got a whole bunch of information here. I've got where my derivative is 0, where my second derivative is negative. I've got function values. And so they've given us a whole bunch of information here. Where I start when I start the graphs is I start with the function values. So I'm going to highlight those starting points. So you'll see it's f of negative 3, f of 2, and then I missed one over here, and f of 9. And so remember what those points that I've highlighted means. F of negative 3 equals 8, well, that's the point x is negative 3, y is 8. F of 2 equals 1, well, that's the point 2, 1. F of 9 equals negative 6, that's the point 9, negative 6. Alright, so those are going to be important points. I'm going to assume those more than likely are going to be my critical values or inflection points. Alright, so that's the first thing. I start with those. I sort of graph those first. Alright, so I'm going to mark off. So I know I have to go out to 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Alright, so this would be my 9. And so 9, negative 6. 4, 5, 6. Alright, so I'm going to mark that point off. So 9, so again, I'm just plotting points right now. 9, negative 6, 2, 1, and negative 3, 8. Alright, so all I did was plot points. Right, that's it. The points that they gave me. Now, based on this, just my knowledge of it, I'm going to guess that the 2, 1 is an inflection point. The negative 3, 8 and the positive 9, negative 6 are going to be critical values. But I don't know that. It could be a weird kink in my... One of them could be with that S shape, and it might not be. Alright, but right now, that's all I have. I just plotted those points. Alright, now I'm going to look at... The next thing I'm going to look at is where my derivatives are 0. So this one gave me a derivative of 0 here. My first derivative is 0 there. And my second derivative is 0 there. Alright, so that now tells me that my guess was correct. Right? When my first derivative is 0, that's a critical value. Which means I should have a horizontal tangent. When my second derivative is 0, well, that's a possible inflection. Alright, so based on that, at negative 3, this should be a critical. At 9, right, it also is a critical. And at 2, well, that's a possible. Right now, it's just a possible inflection. Alright, I've got to check and make sure concavity switches. But I at least know that much about it. Alright, so again, this should be a stopping point, this should be a stopping point, and this is a possible inflection. Alright. Again, my guess is it's going to be an actual inflection, but I've got to make sure everything pans out. Alright, so this one tells me if my... So at x equals negative 3, my second derivative is negative. Alright, which means I tested the value at negative 3, the second derivative is negative, and so that means it should be concave down at x equals negative 3. So at this moment, it should have a concave down shape, which means that's a critical moment. That's a maximum, right? It's a stopping point. That's a maximum. So that means my graph should come up and has a concave down. And so again, right now, I'm just going to kind of draw it out at this moment. I know it should be a concave down shape, and then I'll connect the dots later. All right, the next piece of information I have is the second derivative at 9. So over here at 9, I kind of can do the same thing. The second derivative at 9 was positive. Should I write that down right? Positive. Which means at x equals 9, it's concave up. All right, concave up. And I have a stopping point. And so again, it should have this shape. Well, based on that information, well, now I connect it. Maximum, possible critical point, probably a critical point at that moment. And then curves up. So again, it should have this shape. So now I'm going to kind of finish out the shape that I started. So it comes up, concave down, has to go through that moment. More than likely, that's where it's switching to concave up and going through. And now I've everything checks, right? I've got stopping points where it said it should have stopping points. I've got my possible inflection point, which is probably an actual inflection point, which is where my second derivative is 0. It's concave up where it should be concave up. It's concave down where it should be concave down. And in this one there's probably, because they give us more information, the graph should actually reflect this Where your graph might be a little different than mine is how steep do you make this curve? How do you actually make it an inflection point there, which again you probably should. How curved do you make it? That's where your shape, but it should have this shape to it. Alright, it should have that shape to it. Alright, we'll stop there.